So first we'll work with images. We'll see how images are rendered in .NET. So what we got to do, we can display the images into a control called picturebox. Okay? So .NET has a picturebox control. Okay? Now we can browse and we can browse one image that is just give a button, give it a label called browse. Okay. So whenever we try to select something, we try to open a file open dialog, and from this we try to select. So .NET also has got a file open dialog. What you can do is open file dialog, take an object oft is equal to new open file dialog. Okay. Now I want to show a dialog such that the dialog box is one which will get opened, and user will not be able to do any work on the background of it unless and until either anything is selected through this dialog box or anything is deleted through this dialog box. Okay. So we can show dialog. Okay. Now whenever a dialog is opened, obviously as you can see, no further code will be executed. At this level, whatever code you read, that code will stop here. Only after you have selected something or cancelled something, this dialog box, the next line of code will get executed. Okay. So this show dialog will return something called dialog result. There are two types of dialog result, OK or cancel. So if user has selected some file name, I want to open that file name. Okay. So we generally write it in this fashion. If ofd.showDialog.equals dialog result dot OK. If user has selected something, the file name which he has selected will be present in the file name. Okay. So string fname is equal to oft dot file name. .NET supports an image which is called bitmap. Okay, bitmap is a memory image which will be present in a matrix format, so you can manipulate it. Okay, so bitmap bmp is equal to bitmap dot from file fname. There are two classes in .NET. One is image, one is bitmap. Image is an object which can be displayed but cannot be manipulated. So this from file returns an image object which is inherited from bitmap object. So we can typecast it as bitmap. All we need to do now is picturebox1 dot image is equal to bmp. So it will display me this image. If you run browse, so pictures, the thing is the image is quite large, so whenever you are trying to display, the size of picture box is very small, so only the part of the image which is common to this picture box is appearing over here. I do not want that. I want image to be displayed exactly at the size of the picture box. Okay. So how I can do that? I can take a new bitmap, say b2 is equal to new bitmap. I want to create a bitmap of this BMP. Size should be same as picturebox1 dot size, and instead of assigning BMP to picture box, I will now now assign B2. So no matter whatever their size is, they'll always be resized to the size of the picture box, and I'll be able to see the image no matter whatever the image's size is. Okay, so I should be able to get this image irrespective of the size of the image. It will appear like this. Okay, so this is how we use the bitmap object. Okay, now it is always a good practice to keep the bitmap global, assign it with null, and then why? Because if I do that, under that situation, this can be used by the other functions also. Okay. We also have a control in .NET called slider. Trackbar. Okay, so I want to take a track bar, and I want to give a brightness value. Level. So brightness. I want to change the brightness of the image on the runtime. Okay. This track bar will have a minimum value and maximum value. So when you check out with the property, minimum, let us keep it as 0, and maximum, let us keep it as 50. Okay, so or let us keep it as 100, and its current value, let us set it as 50. So whenever I change the track bar, okay, its value is going to get changed. I want to change the intensity of the image. Try catch. Okay. I want to loop through all the pixels of the image. Okay, so image is a matrix which will be having rows and columns. So for int I is equal to 0, I is less than, because I have made BMP as global, I can access that. BMP dot rows is nothing but the height of the image. Okay, BMP dot height I plus plus. For int j is equal to 0, j is less than BMP dot width j plus plus. In order to fetch a single pixel from the image, we can use getPixel function. Okay, each pixel is a color, so color C is equal to BMP dot getPixel xvalue. So width is let me convert this into width and height. Width and height. So first x value you have to specify I comma j. Okay, each color is a combination of red, green and blue. Okay, so int r is equal to c dot red, int g is equal to c dot green, int blue is equal to c dot blue. Each color is composed of 3 colors. How each color is composed of 3 colors? If we fill it with some colors, if you pick the color in paint and if you say edit color, you can see this color is a combination of red, green and blue. Their values varies from 0 to 255. White is 255. So if I make this as 255 and if I make them as 0, this will be pure red. Okay. On the other hand, if I make it as 255, both as 0, it will be green and so on. So as I change this, get started with this. Okay, so we can get all the three colors. Now if I reduce the trackbar below 50, I want the color to be reduced. If I increase it, I want it to be increased. Okay, so what I can do is R is equal to R plus trackbar 1 dot value minus 50. Okay, so if it is 100, it will increase by only 100. If it is 10, it will be decreasing by 10. Similarly, green color is equal to current color value plus okay, and blue color is equal to blue color plus this. Now I have changed the color. I have to put this color back to the pixel again. So C is equal to new color red, green, blue. Okay, and no, not declaration. The command is color dot from argb. Okay, and bmp dot setpixel C. So I'll first take a pixel, manipulate that, okay, and then again put it back into I and j location. Okay. Now even after changing, I want the actual picture box image to be changed. Okay, so if this operation was successful, picture box 1 dot image is equal to, now recall that BMP size might be different, so new bitmap BMP comma picture box 1 dot bit comma picture box 1 dot, or just we can write picture box 1 dot size. That's it. Okay. So let me browse one image. Just to pick up an image. Let's take this one. Okay. Exception is getting rejected. What is that exception? Value 267. Okay, now see, there is a problem. The problem is that all the values should be between 0 to 255. Okay, so if R is greater than 255, it should be okay. Similarly, if G is greater than 255, it should be restricted to 255. If blue is greater than 255, it should be 250. Similarly, if r is less than 0, it should be only 0. Okay, negative values are not allowed. Similarly, if g is less than 0, it should only be 0. If b is less than 0, it should be 0. So by taking this, let us if I increase the brightness, so already BMP has got changed. Okay, that is why it is showing in this way. Now there is a problem. If I take a large image, okay, when I change its values, I do not know how long this loop is executing. Okay, so after the loop is getting executed, this is going to give me a response, but I don't know what is going on. We already know that this is a case of the actual operation blocking the UI thread, and we know how to solve this problem. Okay, we can solve this problem by using a technique called background process. Okay, so particularly because of this problem, we designed background process. Okay, so what we are going to do is, we are going to first take a progress bar in order to show what is going on. Okay, so we'll now take a progress bar. Okay, as this is getting changed, this whole code we are going to remove from here. We'll take a new background process. Okay, so background worker is equal to new background worker, bw dot do work. Okay, this whole code should come within do work. We should also mention bw dot worker supports cancellation is equal to true, bw dot worker reports progress is equal to true, bw dot progress change progress bar 1 dot value is equal to e dot progress percentage. Here demonstrated in console program with 1, 2, 3, 4. Here we can directly demonstrate. And this part we are going to cut from here and put it inside form load method, so that background process is initialized only once. Whenever the trackbar is changed, we are just going to run the worker asynchronously. In the do work, after every I loop is completed, bw dot report progress. Okay, we have to give the percentage. So I into 100 divided by BMP dot width. Okay, so I by BMP will give us the fraction, into 100 will give us the percentage. Okay, now when we take even a large image, say when we take a relatively very large image and progress bar validation. So make some changes. Okay, track bars scrolling label, that is tick style bottom right, size, step size, tick frequency. Let me take it in terms of 5, and first track bar 1 dot enabled equal to false. So once user moves and when the file is getting opened, we need to write one more code. That is while initializing this, bw dot task completed, run worker completed. So when the worker is completed, at that time track bar 1 dot enabled is equal to true. So browse, I'll take this image, should increase, but the progress bar is not showing any changes. Why? Why the progress bar update is not being shown? Int PC. So whenever it is progressing, in the progress changed, we shall see whether this code is reaching here or not. I will take one image, large image. Progress percentage is 0. It's never coming back over here. Taking multi-threading, okay, it shows that the cross-threaded operation is not possible. Okay, so what we are going to do is int cross-threaded operation, because we have converted it into threading, and this track bar, okay, is nothing but a GUI component. So I cannot use this GUI component from my background process. So I'll use this variable change. So I'll use this variable change, and this variable's value I'm going to set whenever I'm changing the track bar. So once the track bar is getting changed, I'll first assign change is equal to track bar 1 dot value. So in this way you need to trace the error. Okay, whenever your program doesn't work out, just put a breakpoint and see whether it is working or not. Okay, now everything is working fine. Okay, so it's going to show you the that the process is working, and you can see throughout this process this has been stopped. Okay, also I have put a system.threading.thread.sleep of 2 milliseconds. I have put a 2 milliseconds delay. Okay, ideally we do not require this delay. You can keep it as fast as possible. Select your image and try to change the intensity values. This is a huge image. Now you will be able to see how much the image has changed. Once the whole operation is changed, it is going to show the result directly over here. Okay, there is also another problem. The problem is that, look, the way it is not allowing you to use track bar over here, the same way it will not allow you to use picture box also over here. Okay, because picture box is also a GUI component. So whenever your task is completed, get that into run worker completed task. So calculate the task, the result should be updated. One of the things is just convert the image into, say, grayscale image. It is one of the effects. Okay, so say grayscale. Here is converting the image into grayscale. Now how do we do that? I'm going to show you without background process. Okay, you can later, while practicing, put it inside a background process. Okay, so any image can be converted into background process if you make, converted into grayscale if you make there all the 3 channels value as same. Okay, so here I do not have to do anything. All I have to do is make red, green and blue as same. Okay, so green is equal to red and blue is equal to also red. Okay, finally once it is been done successfully, picturebox1 dot image is equal to new bitmap picturebox1 dot bmp comma picturebox1 dot size. So running, what is happening? Oh, it's running. Very surprising. Did not written background process. How background process got connected with this? Have not written any background process. Oh, I'm sorry. It still has this bw.report progress. Okay, very good. I discovered that even without running a background process, you can. Okay, so any image can be converted into nice little grayscale images. Okay. Using this method. Okay, so in this way, we can manipulate the images by putting setpixel and getpixel method. Okay. Also, I'll do a very simple application of putting a watermark on the top of the image. So let's take a where is it? Group box. Watermarking is nothing but adding some text over the image. How do we add the text? We need to take a graphics object. Okay, graphics G is equal to graphics dot from image BMP. So if we make the BMP as global, once we open, this will be accessible from everywhere. Then I can write G dot draw string, set around 10 pixel. I'll leave from left, 10 pixel from top. The string is txt name dot text, whatever name you have given, font, new font, font family, let us take Tahoma, comma size 16, comma it expects a color. Okay, so you can declare a brush, new solid brush, declare a solid brush. Solid brush should have color, so color dot red. Okay, comma which point, new point 10 comma 10. So at point 10 comma 10 with a solid brush with red color, I want to draw a string. So I'll browse an image. Having done that, picturebox 1 dot image is equal to we'll browse an image. Okay.